All right, let's start with this question. This question appears in IB in past paper, 2 mark questions, and I have already highlighted the key information of the question. So state as a command word, and then full electron configuration, and then is oxygen atom. That's the first part of the question. The second part of the question is number of unpaired electrons in that atom. So let's start with the first part of the question. So the first part of the question is writing the full electron configuration of oxygen atom. In order to that question, so we will look into our data booklet or periodic table, and that will help us to figure out how many electron oxygen atom should have. So oxygen, atomic number for oxygen is 8, hence there are 8 electrons. So we need to start filling from the first shell, so 1s2. So first shell is complete. We move into the second shell, so 2s2 and 2p4. So this is a full electron configuration of oxygen atom. That will give us 1 mark straight away. Let's move to the second part of the question. So it says the number of unpaired electron in that atom. So in order to do that, we need to write down orbital configuration, or sometimes we call it box configuration. So we know orbital is a region around the nucleus which can have maximum 2 electron with opposite spin. And in higher class, we say is a region around the nucleus where the probability of finding the electron is maximum. So we need to write down orbital configuration. So 1s2, so electron will go with opposite spin. So they are paired. In 2s, we have a pair of electron. And we know a p subshell, there are 3 orbitals, px, py, and pz. So Horn's rule says when there are orbitals of equal energy available, then electron, they go one by one, and then they paired up with opposite spin. So 1, 1, and then we'll start pairing up from here. So we can see there are 2 unpaired electron in P. And hence, if we write 2 unpaired electron, we'll get the second mark.